Welcome to this episode of Easy Physics. Today, we will be exploring the fascinating concept of the gyroscopic effect. The gyroscopic effect, also known as gyroscopic stability, is a phenomenon that occurs when a spinning object experiences a force that acts perpendicular to the direction of its rotation. This force allows the object to resist changes in its orientation, making it highly stable and predictable. To understand the gyroscopic effect, let's start with the basics. Imagine a spinning top or a bicycle wheel. When these objects are spinning, they possess angular momentum, which is a measure of their rotational motion. Angular momentum depends on the mass of the object, the speed of rotation, and how the mass is distributed about the axis of rotation. Now, let's look at what happens when an external force is applied to a spinning object. According to Newton's first law of motion, an object at rest tends to stay at rest, and an object in motion tends to stay in motion with the same speed and in the same direction unless acted upon by an external force. This concept is known as inertia. In the case of a spinning object, the gyroscopic effect comes into play due to the conservation of angular momentum. When an external force is applied that tries to change the object's orientation, the gyroscopic effect causes a torque to be exerted at right angles to both the applied force and the axis of rotation. This torque is known as precession. The key to understanding precession lies in the conservation of angular momentum. According to this principle, the total angular momentum of a system remains constant unless an external torque acts upon it. In other words, the spinning object resists changes to its angular momentum. To see how this works, let's consider the example of a gyroscope. A gyroscope consists of a spinning disc mounted on an axis, allowing it to rotate freely. When the gyroscope is spinning, it possesses angular momentum. Now, if an external force is applied to the gyroscope, such as an attempt to tilt it, the gyroscopic effect comes into play. Instead of tilting immediately, the gyroscope responds by precessing. This means that it starts rotating around a different axis perpendicular to both the applied force and its original axis of rotation. This precession is a consequence of the conservation of angular momentum. The gyroscopic effect can be explained using the right-hand rule. If you imagine gripping the axis of a spinning gyroscope with your right hand, with your thumb pointing in the direction of the axis, and your fingers curled in the direction of rotation, the direction of precession will be perpendicular to both your thumb, representing the axis, and your fingers, representing the direction of rotation. The gyroscopic effect finds practical applications in various fields. For instance, gyroscopes are used in navigation systems, such as aircraft and spacecraft, to maintain stability and accurately measure changes in orientation. They are also used in mechanical gyro compasses and inertial guidance systems. Furthermore, the gyroscopic effect is essential in sports and vehicles. For example, the stability of bicycles is largely due to the gyroscopic effect. The spinning wheels of a bicycle create a gyroscopic effect that helps maintain balance. In conclusion, the gyroscopic effect is a fascinating phenomenon that arises when a spinning object experiences a force that acts perpendicular to its rotation. This effect is a consequence of the conservation of angular momentum and results in precession, where the spinning object rotates around a different axis. The gyroscopic effect provides stability and resistance to changes in orientation, making it an integral concept in various applications ranging from navigation systems to sports.